of Montreal, Polytechnique Montreal, and he will be talking. The last talk is a good segue to his talk on interactive model reporting and analysis using NLP. So that's a kind of a complementary approach to allow users to analyze models using natural language. So, Mohammed, floor is yours.
Okay, well, thank you, Majid, for the invitation to have the talk. And yeah, I think some of the, raised concerns that have been raised in the previous presentation, maybe you will find some answers for in this presentation. So, so the talk is about interactive model reporting and analysis in openCAESAR. This is a collaborative project between NASA GPL with like Majid and my master student Thomas. And before we start, today, in fact, is the birthday of my daughter. So unfortunately, because of the work, I can't be with her. So I promised her that you would help make her day special. So if you can take a moment, just maybe all together to say happy birthday to her. I promised her that I will record this to her.
Happy
So
birthday.
I will count to three. I'll count to three. So 1, 2, 3. Okay, happy birthday, Lulu.
Happy
Happy
birthday.
birthday.
Happy birthday.
Thanks, everyone. Okay, so as part of our ongoing collaboration with GPL, in 2023, we launched a project to build a tool chain within openCAESAR for electronic data sheet. These data sheets that normally used for as blueprints for specific cloud subsystems or other system specifications. So the goal of that tool was to capture all components, definitions, interfaces, parameters, and behaviors in a structured machine-readable way, and to provide the visualization for this. So we developed the vocabulary in OML, implemented the authoring tool, and some translation from the OML to the electronic datasheet XML format. And we tried to automate some of the reporting and the viewpoints as much as we can with limitations. So you can access this work through this QR code. So the stakeholder and what was through this project, we were collaborated with Nathan Benz from NASA Amos project. And as we progressed in this project and through conversations with Nathan, we uncovered some of the recurring pain points that stakeholders normally and frequently encounter as they work with such tools. And particularly the comment that Nathan made, that, well, they have to create these presentations, normally in PowerPoint, that where they can report on the progress of the project, or in fact report on some of the components used in the project, and they need to interact with the model. So they need to do reports, and these reports need to be interactive. They need to be based on the live data that's available. And this is typically hard because normally it's done manually. And if we will do this in automated way, then we need a way to interact with the model. And this start the discussion about the project that we have today, which is an interactive reporting framework that will integrate with Jupyter Notebook, similar to Code Lab or Colab from Google. So we have model laboratory here that will enable us to interactively communicate with the model and send our query. So here the stakeholder will send the question in natural language, And this question need to be translated into Sparkle queries as we're using here. We're trying to integrate with openCAESAR and OML and ontologies and RDFs. This will be executed and then rendered to visualize the results in the most suitable way to report. Now, of course, the universal hammer that someone will think of, in this case, using LLMs, which is everyone using these days, to do such work. Unfortunately, general LLMs lack knowledge about MBSE specific terms and relationships. MBSE domains also lack large training data sets. So if we look at these models that we want to interact with, normally those are private models and open data sets. We have scarcity of them. User queries normally vague when they're expressed, as also highlighted by Nicholas in the comment in his last comment. They're imprecise, require deep contextual understanding, so they need to be grounded. So maybe just going from natural language to Sparkle would be in one shot, maybe not the best option. So directly generated Sparkle normally also error prone and break easily with minor mistakes, and may result also in silent errors if it's executed. So in order to address all these challenges, we decide to build what we call MBSE domain expert LLM for model reporting. So we use LLM to generate controlled natural language queries. So here we selected and we decided to go with Squall, which is a controlled natural language can be translated and have deterministic way of being translated into Sparkle. However, also we wanted to build a generic Squall expert model using existing question and answer datasets. And because the existing question answer datasets that is normally available, it's for Wikipedia and it's not tailored for system engineering. So we decided first to create a generic expert model and enable us to generate Squall with its placeholders. So to learn the generic relationships, then specify it as we will see in the approach. And we used also RAG, but a modified version of RAG that works for graph and RDFs. And we apply also what we call domain adaptation to fine-tune lightweight models. So instead of using the expert model that we have, the generic one, the generalizer, so we can have another, freeze this model and have another layer of a lightweight model that will learn the specific details and terminologies of the domain. So here is a generic overview of the three phases that we have. So we started with a generic data set of questions and answers that can generate sparkles for of ground truth sparkle for the corresponding questions. We prepared this data set to create Squall equivalent of the Sparkle with placeholders. This is a process, of course, so it's not, I'm hiding many of the details here. So for example, we take the Sparkle, we convert it to controlled natural language, we identified the URIs and replace them with the placeholders and so on till we get the Squall equivalent. So we get the data set here that you can see it, which is natural language Squall pairs. This is used to fine-tune a llama model, and we get the Squall expert here that is able, given a question, to generate Squall equivalent for it with placeholders. We froze the model, so we we don't change the weights anymore. Then we get another data set that is we can run questions against a knowledge base in this case with system engineering concept. We use this, and we use like the PCST algorithm to query the graph and to have subgraph that is related to the question. And now we're feeding the frozen model the squall, the question, and the subgraph, and ask it to generate a squall query. Now we use the grounded truth and the squall query that is generated to fine-tune another model, which is the domain expert layer that will used as the domain expert. So we have the squall expert and the domain expert. Both of them create what we call the domain-specific expert. We use this domain-specific expert, so we have given the question, and the graph, like subgraph. So we apply again the retriever, but here in the inference domain mod. Given to the expert model, it will generate the squall that will go to translator, deterministic translator, and then linker that replaces all the placeholders with the actual corresponding entities and relationships from the domain model, and this generates the Sparkle query. So given the question, we generate squall with a placeholder using the domain expert. Using the translator, we can generate the Sparkle query with the placeholders, and then using the linker, we can specify this to the knowledge base that we have. We evaluated this using like a blue metric, a blue score, and we evaluated against one of the baselines that is used normally in these situations, the KGQ QN, and the results, in fact, is phenomenal in terms of the accuracy, execution accuracy, and also the blue score, and the failure rate is very low in our case. And this is using Llama 7B, which is very small model. So if we use more advanced models, most likely we will get better results. So this is an overview of this project. So we try to bridge the gap between MBSE models and the stakeholders using LLMs, retrievals, and linking, and enable flexible interactive model reporting. We provided generic architecture in modular way that is adaptable and data efficient. I will take this opportunity also to remind you to send your work, send your papers to the ontoNexus workshop, the next one that will be in October, which will be with models in Michigan. I see many nice presentations through the day and yesterday. So all these would be interesting and nice to report about. If you can even just write about what the work that you have, I think that would be interesting to the community. Thank you so much. So if you have any questions, I'm here.
Thank you, Mohammed. I think there is a question in the chat. What artifacts did you find work best for better results, i.e. industry best practices, such as in COSI, System Engineering Handbook, sample models, etc.?
Yeah. So, the of course, the quality of the data sets that we have, if we can have high quality data sets, we will get better results, and we can customize the domain expert for that domain. So for the cases that we have, the data set that we used, which is the scientific question answer over the ORKGE, this have many system engineering concepts, but still it's more scientific questions answers data set. It would be better if we can have more system engineering data sets, but there is from our knowledge and based what we find on the public domain, we were not able to find like pure system engineering data sets with the questions answers. So if you have access to any of these, that would be great. But again, handbooks, other data sets that's available could be probably used to synthesize data that is related, that is system engineering specific.
Thank you so much, Mohammed. And I want to echo your message